Okay, hello Cloud Gurus, and welcome to the very last theoretical lecture of this section of the course. So this is on Storage Gateway. Now, I'll be honest, I did the exam about 2 days ago, and Storage Gateway didn't come up. However, it used to be a very popular exam topic, and you should still know what it is because a lot of people do use Storage Gateway to move data into AWS. So what is Storage Gateway? Well, it comes in a bunch of different flavors, but basically it's a service that connects an on-premise software appliance with cloud-based storage to provide seamless and secure integration between an organization's on-premise IT environment and AWS's storage infrastructure. And the service enables you to securely store data to the AWS cloud for scalable and cost-effective storage. So what does that actually mean? Well, let's have a look at our data center. So we've got Storage Gateway here, and Storage Gateway is basically a virtual or physical device, and it's going to replicate your data into AWS. Now, it always used to be a virtual device, but they have released hardware appliances now, so you can actually have a physical Storage Gateway as well. So Storage Gateway's software appliance is available for you to download as a virtual machine image that you install on a host in your data center. And Storage Gateway supports either VMware's ESXi or Microsoft's Hyper-V as the hypervisor. So a hypervisor is just what you run virtual machines on. And once you've installed your gateway and associate it with your AWS account through the activation process, you can use the AWS Management Console to create the Storage Gateway option that is right for you. So Storage Gateway comes in effectively 3 different flavors, and they are as follows. So we have our File Gateway, and this is either NFS or SMB. We then have our Volume Gateway. This is using iSCSI. So File Gateway is basically a way of storing files in S3, whereas Volume Gateway is a way of storing basically copies of your hard disk drives or virtual hard disk drives in S3. And there's 2 different types of Volume Gateway. You've got your stored volumes, and then you've also got your cached volumes as well. And then finally we have Tape Gateway, and this is a virtual tape library. So let's go ahead and have a look at all of them. So we'll start with File Gateway. This is basically where files are stored as objects in your S3 buckets, and they're accessed through a network file system or NFS mount point. And then ownership, permissions, and timestamps are durably stored in the S3 in the user metadata of the object associated with the file. And once objects are transferred to S3, they can be managed as native S3 objects, and bucket policies such as versioning, lifecycle management, and cross-region replication can apply directly to objects stored in your bucket. So you can have all the goodness of S3. So it's basically a way of connecting your on-premise infrastructure to S3. So here's a good example. Got our application server here. It's using an NFS mount point to Storage Gateway that then connects in over the internet or over Direct Connect, which we're going to cover off later on in the networking section of the course, as well as Amazon VPC. And then it's going to store your files in S3. And this diagram is slightly out of date. It has S3IA, doesn't have S3 with intelligent tiering, and it doesn't have the 2 different types of Glacier, but you get the point. It basically is a way of storing your application server's data into S3. So that's all File Gateway is. Volume Gateway is basically presents your applications with the iSCSI block protocol. So basically you can use virtual hard disk drives, and data written to these volumes can then be asynchronously backed up as point-in-time snapshots of your volumes and stored in the cloud as EBS snapshots. And the snapshots are incremental backups that capture only changed blocks, and all the snapshot storage is also compressed to minimize your storage charges. So Volume Gateway basically is a way of storing your virtual hard disk drives in S3, and it looks like EBS snapshots. Now, don't worry, we haven't covered off what EBS is yet. We will cover that off in EC2 in the very next section of the course. But just think of Volume Gateway as a way of storing virtual hard disk drives in the cloud. And it comes in 2 different flavors. We've got stored volumes, and this allows you to store your primary data locally. So you always have a complete copy of your data locally in your data center, and it's backing that data up to to AWS. And stored volumes provide your on-premise applications with low latency access to their entire data set. So with stored volumes, it's really important to remember that it's the entire data set. And it's going to provide durable off-site backups. And you can create storage volumes and mount them on an iSCSI drive from your on-premise application servers. And then data written to your stored volumes is stored on your on-premise storage hardware. And this data is then asynchronously backed up to S3 in the form of EBS snapshots. And at the moment, it's between 1 gig to 16 terabytes in size for stored volumes. If that has changed, don't worry about it. You're never going to be tested on, volume sizes in the AWS exam. It's always going to be scenario-based questions. So this is what it looks like here. We've got our users and our client. They're using the application servers. This then uses an iSCSI connection to our host. And this is our host is running our gateway virtual machines. And essentially, we're creating volumes on this host. And then what's happening is the virtual machine is then replicating these volumes up to AWS and storing it as snapshots in S3. Cache volumes is slightly different. So you do have to remember the differences between them. And cache volumes is basically, it doesn't do the entire data set locally. It is only doing the most frequently used data in your storage gateway. So cache volumes minimizes the need to scale your on-premise storage infrastructure while still providing your applications with low latency access to their frequently accessed data. So you can create storage volumes of up to 32 terabytes in size and attach them as iSCSI devices from your on-premise application servers. Now, your gateway stores the data that you write to these volumes in S3, just like the last one, and it retains recently read data in your on-premise storage servers gateway's cache and upload buffer storage. So it's between 1 gig and 32 terabytes in size for cache volumes. Again, don't worry, you'll never be tested on that. It's just important to understand that cached volumes is a way of caching the most actively used data, whereas with stored volumes, it's the entire data set. So again, here's a diagram. We've got our users, we've got our application servers. It's connecting in through iSCSI to our host, and our host is running our virtual machine gateway, a gateway VM. This is also accessing SAN, so storage attached networking, and again, that's just like basically a big disk. And then the gateway VM is replicating our information over to S3. So that's how that one works. And then finally, we have Tape Gateway. It offers durable, cost-effective solution to archive your data in the AWS cloud. So it's a way of getting rid of tapes. The virtual tape library interface it provides lets you leverage your existing tape-based backup application infrastructure to store data on virtual tape cartridges that you create on your Tape Gateway. So if you are already using tapes and different applications software that connects into tapes, you can actually replace your entire tape infrastructure and just use Tape Gateway. So it's a really great way of moving your backups to cloud. And so each tape gateway is pre-configured with a media changer and tape drives, which are available on your existing client backup applications as iSCSI devices. And you can add tape cartridges as you need to archive your data. And it's supported by really popular backup software like NetBackup, Backup Exec, Veeam, etc., etc. And this is what it looks like. So over here, we've got Data Center A, Data Center B. We've got our tape drives. This is running as a gateway virtual machine. So this is our storage gateway. And essentially, it's just replicating our virtual tapes to S3. And of course, then you can archive them off to Glacier as well to keep your costs low. So that is it for Storage Gateway. Like I said, I did the exam a couple of days ago, and it did not come up at all. It may well have just been moved over to the SysOps Administrator Associate. It is a critical subject to understand going into your SysOps Administrator Associate. That being said, it is also important to understand it if you do work as a solutions architect, especially if you're working with a company that's moving to AWS and they've got a virtual tape, they've got a tape library. It's good to know that you can actually leverage Storage Gateway to move that over to virtual tapes and replicate it over to the cloud. So what are my exam tips? Well, we've got File Gateway. This is NFS, and it's for flat files, and it's going to be stored directly on S3. We've got Volume volume gateway, which is using iSCSI, and it consists of two different volumes. So we've got stored volumes. Stored volumes is your entire data set to be stored on S3. Then we've got cached volumes, and this is where your entire data set is still stored on S3, but the most frequently accessed data is cached on site. And with stored volumes, the entire data set is stored on site. So that's the difference. Stored volumes is you've got your entire data set on site. Cache volumes is where you've only got your most frequently accessed data cached on site. And then we also have Gateway Virtual Tape Library. And I have been, like I said as well, we were talking about that these were virtual appliances or virtual machines. You can also get physical storage gateway appliances as well now. So that is it for this lecture, guys. You've done really, really well. You're at the end of the S3 and IAM section of the course. In the next lecture, we're just going to summarize everything that we've learned. So if you've got the time, please join me in the next lecture. Thank you.